Hi everyone. I just wanted to do a really quick demo for you of total internal reflection, specifically this first page, which we're using the Phet simulation again. So just as we did last time, we're going to click on the link and we have a few different settings this time. I'm just going to show you what those settings are. So this time we're actually going to change the materials. Here, we're going to have the material water, and our material 2 or medium 2 is going to be air. So again, we have the laser, which we had used previously. Right now, what I'm showing is refraction, what we saw last week, but there's also something else going on, which we didn't talk too much about. That's this ray up here that's actually being reflected. So that's what we're exploring today, actually. We're also going to need our protractor, so I'm just going to drag that out here. And don't worry too much about this being exact. I know that it's a little bit glitchy, but don't worry about that. And really what we're doing here is for each of the angles of incidence we've been given, which are 10, 20, 30, and so forth, we are setting up our laser and we're seeing what happens. So for the first value we are given, we have a 10-degree angle of incidence. And down here we can see there's around maybe 14 degrees angle of refraction, so measuring down here. So again, that's really the same as what we did last week. So over here, I would write in 14. Now, the part that's a little bit different is over here, qualitative observation. So this is describing what we see. And I mentioned some examples here, is light reflected or refracted and so forth. So in our example, we can see refraction for sure. The light is bending as it moves through into a second medium, but we also see this little bit of reflection up here. So in my description, I'm going to write something to that effect. So just as an example, I can see that light is refracted as it enters medium 2, which was air. And light is reflected to stay within water, which was that second ray that we saw coming up here. Now you can add more stuff. You could add like the measurements that you see here and so forth. For now, I'm going to keep that part really brief, but essentially you're going to be doing this for every single one. Now, when you reach, so when we get to 50 degrees, you're going to see that I've left the eye blank, okay? And what I want you to do for that is that I want you to see where the angle of refraction becomes 90 degrees. So I'm going to just give you an example here. Up to 40 was already shown on the chart. Once I keep going past that point though, notice when I get to 50, I see that angle of refraction is 90 degrees. And what we call this actually is total internal reflection. That means that the light stays completely within the first medium. It doesn't pass into the air at all. So going back to here, we would fill in that angle of 50 for our critical angle, which is I. And you're going to see as you keep reading through the notes that critical angle is, again, really important property that we're going to find useful in lots of different places. So I'll let you guys continue reading through the notes for that, but that's just how you're filling in this table. Don't worry too much about these angles being perfect. Once you pass 50 degrees, let's say when you get to 60 degrees, I'll just show you quickly, you're going to notice there is no refraction. So in our table, we're going to write that we see internal reflection, but we see no refraction. So that's sort of how you fill in this table.